Hi, I'm John Paulraj, and I'm on a mission to make the learning of math fun. If you're new to this channel, do consider subscribing. This video is part 2 of cracking functions with TI Nspire CX2. If you haven't already seen part 1, the link will be somewhere up there. I will mention the link on the description below. So, let's continue. This is variant 3 of the same October-November session 2020. And this question is an interesting question, okay? Question number 8. Again, the first part of the question was to sketch the graph, meaning you have to give the details, okay? The function given is y is equal to 1.5 to the power of negative x, and those are the values given. The first part is to solve the inequality. They have been asking this inequality, and that's why I explained, okay? As you can see, you want to solve, that's the function. When is the function greater than 0.5, and when is it less than or equal to 1, okay? So this inequality seems to be a repeated theme that's happening. So I'm going to do part 1 and part 2 on the calculator. Here we go. Let's insert a new problem again. So I go and insert a new problem, and again I will do this on the calculator page, defining on the calculator page. So f of x I have defined as, what was that, 1.5 to the power of a negative x. All right, there we go. Do we need any other function so that we can define before? Comes later on. Okay, I'm going to hit enter. Done. Go to the graph page, and it will, as usual, show me that graph entry line. And you can first go and change the settings. That's a good habit. So I'm going to make it -2. What was there? 4. This was a 2. And what was this here? 0. Okay. Now, let's draft the function, tab f of x. That grasps the function. There you go. And as I said, when you are sketching the graph onto the paper, make sure that you indicate, in this case, you're seeing the y-intercept. What you see is what you need to sketch, okay? So if you're able to see only the y-intercept, do that, all right? So I'm going to use the trace option, and bang, it shows me the y-intercept as it is, and I can just record it by hitting enter, and then I can hit escape, okay? So that is just to show you where the y-intercept is, and that you can just copy the sketch down. Now, the second part says solve the inequality, -1.5, the graph, when is it above 0.5? So I'm just going to hit tab and say, okay, 0.5 is a new function, and that's a red color graph, okay? And you can see that when is the graph above this? Well, actually, it was a joint inequality, as you can see in the question. What I mean by a joint inequality is that you want to solve this kind of inequality. When is the graph above 0.5 and when is it below 1? Okay, so let's draw 1 also. Fx equals 1. That's the graph. Okay, so when is the blue graph between the two? That's the question. When is it below 1 and when is it above 0.5? 0.5 is a red graph. The label, I just moved it around. So let me bring it back. So the red graph is 0.5 and the black graph is 1. The blue graph is our function. Okay, so the question is, when is it sandwiched in between those? So again, you can look at the point of intersection. This one is clearly the y-intercept, but I'll do it anyway. So you can go and use geometry, intersection points. And when I say this is my graph and this is my graph, and as you can see, it gave me 0, 1 again. And do the same thing for the red graph and the blue graph, and those are the coordinates. Again, use my strategy tip that copy down these values before it gets crowded there. So the solution to this inequality, the joint inequality where f of x is below 1 and above 0.5, that's how I want you to interpret less than and greater than. Okay, when is a graph greater than something is when it is above. All right, so when I write the answer, I'm going to write it as x must be less than or equal to 1.71. Is this visible? All right, and greater than or equal to 0. Okay, the next question is about solving the equation. That's our f, and that's another function, x squared, and we want to find where they're equal. Again, points of intersection. So let's get back to our calculator and do this thing quickly. You can even enter the function directly onto the graph page, as I said before. So let's do that. Let's try that this time. So I'm just going to enter x squared. Okay, and as you can see, when things get crowded, probably the better thing was to hide this thing before. So in order to hide, I'm going to go top arrow key and hide the earlier functions. So this one is hidden, that one is hidden, and maybe even gets let's hide this point, or maybe we just need to delete this point. So there you go. This point goes off. This point goes off. And so the blue function is our f of x, and the magenta function is the graph of x squared. We want to find whether these two are equal, which means the point of intersection, menu, geometry, points and lines, and intersection point. And there you go. When you hit this, you get the 2 points of intersection. And before things get too crowded, like I said, please make a note of it. Okay, so that's where the two become equal. X values are negative 1.3 and 0.843. I'm going to record it as it is here. So can you see? Yeah, you go. So x is equal to negative 1.3 and 0.843. Cool. Now, the fourth part of the question is interesting. It says shade the region where the function f of x is less than the quadratic less than. There's a lot of emphasis on less than, greater than in this 2020 session, the October-November 2020 session. So the understanding is important, that, which one is above. So in this case, obviously, we're talking about where the quadratic, the magenta graph, when is the quadratic graph above the f of x, right? Yeah. So as you can see, the magenta graph is above the function f of x before, that means on the left-hand side of negative 1.3 and on the right-hand side of 0.843. So the point of intersection is a very, very important indicator for us, whether you're solving the equation or whether you're solving an inequality, something like this, where x squared, which is the magenta graph, when is it above or greater than the given function? So switching back, as you can see, when is this function, the magenta function, x squared, greater than, okay, which is the same thing as saying when is f of x less than the x squared function. So they have asked you to shade the region. So how do I do this? Let me just go back here and make a sketch so that it'll, so you can see that. So if this was our graph, maybe make sure that I get this right. So this was, let's say, if that was the graph of a function, and then let's say, since we used magenta, let me use a color that was similar to that. That's your not a great sketch, but okay, something. And I should have 2 points of intersection. So let's indicate the point of intersection here. This one is negative 1.3, comma 1.7. And here we've got, what is that? 0.843, comma 0.711. And they've asked it to shade where the magenta or the x square graph is above the f of x. And so you can just use a nice color or something and just shade that part, okay? Shade the part, shade the region where it's above. And I think that's what is asked. Shade the region. Yeah, there you go. That was what is asked. Cool. The next question, part B, is that's also interesting, where they've said the diagram shows the sketch of a graph of y is equal to 2x plus b, negative 2x plus b divided by x plus a. The asymptotes of the graph are x equals 2 and y is equal to negative 2. X equals 2, so you can just make a quick note of that here. So if that's 1 somewhere, that's where the line is going through. That should be x is equal to 2. The graph passes through point 0, comma 2, which is our y-intercept. So that should be 2 there. And so this is x is equal to, y is equal to negative 2 is the horizontal asymptote. So let's just do the horizontal asymptote also there. So here you go, negative 2. There you go. Find the value of a and b. For vertical asymptote, we take a look at the denominator becoming 0 as no factor is cancelling with the numerator. For those of you who haven't yet seen my video on vertical asymptotes and holes, I'll put the link in the description below. Take a look at that, okay? So x plus a is where, so x plus a is what you want to focus on for the vertical asymptote, meaning x is equal to negative a is where the vertical asymptote will be. And if they're saying that x equals 2 is the asymptote, which means negative a is equal to 2 or a is equal to a negative 2. So that should be a equals negative 2. And to find the value of b, we make use of the y-intercept and say, all right, y is 2, meaning x is 0 at the y-intercept. So negative 2 times 0 plus b, and x is 0 for the y-intercept. And a we just found out as a negative 2. So when you solve this, you should get 2 times 0, 0, b should be equal to negative 4. Yeah, b is a negative 4. All right. Okay, the next part of the question, we have to we have to sketch the graph of a function. This is another function f of x, where they've given us the conditions. Normally they give you f of x, they define the function and you use the graphing calculator and you, sketch the graph, indicate the key features. But this time they have just given you some characteristics of the graph. They said the asymptotes of the graph are at x equals a, x equals b, y equals k, and that's marked here, with those dotted lines. But there are other things that's indicated. They said that the gradient of the graph is positive for values of x before a. Gradient of the graph is negative for values of x above b, on the right hand side of b, and m is the only local maximum point. The graph does not cross any asymptote. And using this information, you have to make a sketch of the graph. Very good question. So let's do that. Okay. So let's see. The asymptotes are at x equals a. All right. That's x equals a, x equals b, and y equals k. Are we seeing everything? Okay. Let me just make sure that it's in the view of the camera. The other information given to us is that the graph does not cross any asymptote. And that is also important because a function may cross the horizontal asymptote, but not the vertical asymptote. And in this case, if it does not cross any asymptote, that means it's got to be in any of the blocks. Okay, so let's keep that in mind. M is the only local maximum point. So there's no other turning point. M is the only local maximum point. Now this information, this is what we need to interpret. The gradient of the graph is positive. When the gradient of the graph is positive, the function is increasing, all right? And when the gradient of the graph is negative, the graph is decreasing. That's important to know. When is the graph increasing and when is the graph? So that's the shape. And they've said that for values of x before a to the left-hand side of a, the gradient of the graph is positive. That means it has to be increasing in that region. Now, if I draw it here, then it will be cutting or crossing the horizontal asymptote. So it can't be in this block. It must be in this block. And so the condition that it is increasing, can you guys see? It's increasing and satisfies the condition of the horizontal and the vertical asymptote is fine. Is that right? It can't be this other shape, which I'm going to draw and show to you. It can't be this one because then it will be decreasing, right? So it has to be increasing, and it has to increase from there because, yeah, otherwise it will be crossing, as I said. So for that part, that's good. And then it says m is a local maximum. Now, if it has to be maximum, it has to be concave down. It can't be concave up. Otherwise, you'll have a minimum. So that for that part, it will be asymptoting from here, there to there. All right, that's good enough. It's not very artistic. Let me try and see, what I can do, how best I can do. So I go this way. That's better. Okay. And the third part, it says that for values of x after b and the right hand side of b, the gradient of the graph is negative. That means the function is decreasing. That's b, and decreasing, and it cannot cross again. It must be something like this. I really like this question because only in IB the students learn about curve sketching, but it's very interesting that in November 2020, they've asked this kind of a question. Normally they ask you to sketch a graph using the calculator, but with this kind of information given, first time I'm seeing a question like this. So great question. If you found this video helpful, do not forget to like, share, and subscribe. And if you need explanation or clarification on any of the other topics, do mention in the comments below. I'm going to see you in the next one.